Welcome to Let's Talk, a podcast by the Electrochemical Safety Research Institute at UL Research Institutes. In the Let's Talk podcast series, we share conversations with experts and scientists in the field of energy storage systems, safety science, and standards, and learn about their experiences and vision. Batteries are ubiquitous in our daily lives, powering personal electronic devices to electric vehicles. Batteries are an important piece of the puzzle as we work towards lowering our carbon footprint to tackle climate change. Department of Energy National Labs are at the forefront of developing and advancing batteries and sustainable energy technologies. To talk about the role of National Labs in advancing battery energy storage systems, our guest today is Dr. Ahmad Pesaran. Dr. Pesaran is the Chief Energy Storage Engineer for NREL's Energy Conversion and Storage Systems Center located in Golden, Colorado. At NREL since 1983, his work has spanned various technical areas, including building efficiency, ocean thermal energy conversion, advanced air conditioning, and in the last 25 years on automotive batteries. He has co-authored more than 150 journal articles and technical papers on energy storage and electric drive vehicles. Hi, Dr. Pesaran. Welcome, and thank you for accepting our invitation to have this conversation.
Hello, Tapesh. Thank you very much for a kind word and inviting me to participate in this important, timely conversation about electric vehicles and their batteries.
Dr. Pesaran, you have quite an extensive list of qualifications and responsibilities. Can you please talk about some of the work you do at NREL that are related to batteries?
Sure. I led the NREL R&D effort to enhance thermal performance of electric vehicles and their batteries, develop high-energy cathodes and anodes, improve lithium-ion battery safety, and extend life of their batteries. I was technical director of the DOE program called Computer-Aided Engineering Batteries. It was $50 million, 10 years, and the purpose was to develop several electrochemical thermal models and simulation tools that now is usually being used by many companies. And in the past few years, I have been advisor to Department of Energy's Technology Office, Vehicle Technology Office, providing technical assistance on managing several battery material processing, cell manufacturing, solid-state batteries. Personally, in addition to continue my research interest in the lithium-ion battery cycle life and also improving their safety, I've been leading a project to develop a database of North American lithium-ion battery supply chain.
Oh, great. So talking about lithium-ion batteries, right, they have revolutionized many industries, including transportation, since its invention. DOE labs specifically have contributed greatly to this development and advancements of battery technology. Can you please expand on the contribution of DOE labs and NREL's role in supporting the technological advancements in lithium-ion batteries?
Sure. Yeah, DOE definitely has supported research and development of lithium-ion batteries at national labs, universities, and industry over the last 25 years at least. Their effort has been focused on reducing the cost and volume and weight of batteries, while simultaneously improving their power, energy, durability, and ability to tolerate abuse conditions. DOE and private sector with their partnership have their effort has resulted in significant improvement in energy, longevity, safety, and cost of lithium batteries. For example, in the last 10 years, the energy density of lithium-ion batteries is more than doubled, and the cost has reduced more than 85%. And the cycle life has improved more than 30%, and calendar life more than also 20%. So in the last few years, DOE has started supporting the development of next generation of lithium-ion batteries with no cobalt, because of cobalt is very expensive batteries, and also moving into silicone anodes, lithium anodes, solid electrolyte, and recycling and extreme fast charging at national labs and industry. And NREL, we support DOE in these efforts, all aspects of the battery technology development, like material synthesis such as silicon anodes, and also developing no cobalt cell, and also in addition, just we generally do a lot of thermal characterization, system evaluation. Really these days we use machine learning to actually accelerate prediction of life of batteries and the design, and also improve their lives. And in addition, simulation and diagnostics being used to improve fast charging, and actually we're trying to make it refuel EV fully by less than 15 minutes, which is important for consumer acceptance. So recycling is also an important, we work on that to recover our valued material from recycled batteries.
Great, thank you. So lithium-ion batteries more or less have matured, right? So the focus right now is not just on research, but manufacturing. And most of the manufacturing of batteries is concentrated in Asia. With growing demands for batteries, is there a push to secure a domestic supply of materials and manufacturing? How is the DOE and NREL working towards this goal?
Sure. I think you're right. Right now, 80% of cell manufacturers in Asia, and of global production capacity, China produces more than 70% of cathodes and more than even 85% of anodes. US production is relatively small, maybe up to 15% of production of batteries, cell and packs. And of course, as you mentioned, with growing demand for EVs, US government industry has realized that it's crucial to secure minerals and also from partner nations, and improve processing materials or manufacturing plants in the United States, because we don't want to replace imported oil with imported batteries. So there's a big effort going on. For example, the bipartisan infrastructure law passed by Congress in 2021 allocates more than, if you add everything up, more than $20 billion to mining, material processing, battery manufacturing, and recycling in the next 4 years, 5 years. For example, DOE is awarding $3 billion of first tranche of it into 20 projects to build facilities in the next 4 or 5 years for production of cathodes, anodes, electrolyte, iron phosphate cathodes, and also other components, and do also recycling. So, and it actually, if you add contribution of industry, it also represent more than $7 billion investment. So NREL provide the diagnostic and modeling support to this early stage of some of these projects. I mean, the focus of these projects are mostly manufacturing, but at the beginning, they need to have established what are the best approaches, what are the best materials, and then you build those materials. So there's a little bit of research at the beginning. Also, DOE, in addition, the $7 billion, most of the manufacturing, but also provided loan guarantees for companies like GM and the battery suppliers to create more companies. I think they're projecting that with all the wave of new planned battery facilities, electric battery, vehicle battery manufacturing capacity in North America, by 2030 is projected to be nearly 20 times as of greater than 2021, which is kind of great news. And this could potentially to be US to be more than 35% of global production. I mean, competition still continues in China and Asia and Europe, but I think we will be a strong player with these investments.
Thank you. So you talked about different material shortages and reason to kind of focus on the domestic manufacturing and supply chain. So I came across the lithium-ion battery supply chain database. Can you please tell us more about that? What is it and how to use it?
Sure. This database is basically a directory of all North American companies in the lithium-ion supply chain, such as mining, material processing for battery-grade production, component production like separators or cans or whatever that the battery needs, cell and battery pack manufacturing, and also the end of life, like after the end of life, like battery second use, refurbishing, recycling. And also there are other things that the battery supply chain need, like equipment to produce these materials, services, and also product distribution. So we capture this directory of all these companies, and the companies and their facilities are categorized in upstream like mining, midstream like production of material, and downstream like collection and recycling. The current database is right now is in the Microsoft Excel framework and lists their address of headquarters and where their facilities are, their website, product type, whether it's cathode, anode, or cell, for production capacity, what's the volume per year they produce, and also number of employees, kind of for workforce development, we need to know, track that and kind of help with that, and Department of Energy and NREL. And a brief summary of each what they do. There are more than 520 companies and more than 610 facilities in the database. Some companies has several facilities. Anyone that can use Excel could search and find companies in this specific segment with particular product type, location. Companies can search the database to find suppliers for what they need and also who are the competitors. And one of the neat features of this program is that you can display the location of all the companies and product types on a North American map. And analysts can track the growth of the industry over the last many years and continue it in the future.
That's great to have all the information available in one place. So does the database only contain mature and established companies, or are startups and research labs also included in the database?
Yeah, we try to capture startup companies. We kind of go out and try to send emails to people, or when we see them in new places, we try to ask them to be included. The private research labs are included in database. However, the national laboratories are not included.
So can you talk about why this database was created?
Sure. I mean, NatBat International is a trade association of companies that involved in commercialization of all the segment of the battery supply chain in North America. And they kind of, as a representative of the company of the battery industry, they decided to better understand all the lithium-ion battery supply chain landscape. In late 2020, I think there was all talk about kind of where do these batteries come from. So they were looking to find the list of potential suppliers, not for their own business partners, kind of into the NatBat. And also, more importantly, to identify where are the gaps and the strengths are in the United States and North America, so that it can inform government agencies to tell them, okay, this area is more mature than India, so they invest in those areas, address the issue. In April of 2021, NatBat funded NREL to develop the database of this supply chain, and we published the first version of the database in September 2021, and this database has been regularly used, already been used by DOE to provide insight in selection of the project that recently funded by bipartisan infrastructure law. And we plan to update the database every 6 months because the technology is moving fast and new companies being added, new factories are being also built. So we want to capture that.
So since you led this effort, I wanted to ask you, what was something you learned while you were creating this database?
Oh, it's a very interesting question. I think I learned that to manufacture lithium-ion batteries from beginning to end, we need to have a very diverse and large base of suppliers. Even talking about the minerals, of course, is very easy, but how about the bolts or the production like equipment or the binder all the little details that kind of sometimes becomes very important if you don't have it. So it was important to kind of dealing with all these components and material that are we have to look into. So that was established, that gave me an idea. We have many of these companies that we have to deal with. Another thing I learned was that U.S. Has a relatively strong base in battery pack assembly, and but has a weak supply chain in mining and material processing for battery grade production.
So is this database available for anyone to use, or is restricted to government employees or your industry partners?
No, this this is a publicly available database, and that was the intended of NatPat. So everybody can use it by registering at its website and downloading an Excel file and also a user guide. The website could be easily found by searching the phrase NREL lithium-ion battery supply chain, and it gives you one of the number one. So you click in and you do register, and you were able to download the files.
Great, thank you for making it publicly available. So we're coming towards the end, and I wanted to ask you, your work expands over several years related to batteries and transportation. So what are some of the improvements you would like to see that will increase the adoption of electrified transportation?
Yeah, that's a good question. As you can know, EV adoption can increase by lowering battery costs. I know that we are in a good place, but it's still the battery cost needs to come down. EV costs also need to come down. And so that's one of the aspects of the V-Power with the internal combustion engines. And also, we need to be in par as far as safety of the battery and the electric vehicle. And one of the things is reduced charge time and also wide access to public fast charging. Lower prices can be achieved by not only by volume manufacturing, but also by more innovative and lower cost materials and cells. For example, if you increase specific energy and also reduce material that are not cobalt, less expensive material. So, and it's still the technology is moving fast, and many companies involved to go with high nickel cathodes and also advanced anodes like silicon and lithium metal. And these are still evolving and at the end of the day, everybody's looking for a solid state battery that can play a big role because it has less potential for battery fires because it doesn't have liquid electrolyte, which is organic and potentially flammable. So solid state can play a big role and also reducing cost and improving life. But that one is also in the process and being funded by many companies. Also, a large segment of the drivers that do not have access to home charging. So a large network of fast chargers are needed. And because people also have the experience of driving and going to gas stations and pumping gas in 5 or less than 10 minutes. So we need to be on par with that. And DOE and Department of Transportation are working on that and investing about $7 billion to expand the fast charging network and publicly through the United States. And also last point is education. I think the early adopters are okay with what's going on, but I think there are for majority that coming to market, they need to be educated. What are the charge rate? What are the limitation of batteries, or what are the difference between long range batteries versus short term batteries? There are many. It's like going to have many applications like electric combustion engine that you have 4 cylinders, 6 cylinders, 8 cylinders. So they're going to be lots of these options coming up. So education becomes important.
Great, thank you so much. Thank you, Dr. Pesaran. Your work over several decades is really important, and recently on batteries, we have learned a lot from your work, the work NREL does, and a lot of the research areas that you mentioned, and some of the problems that we still need to overcome. They align with some of the work that our research lab also is doing. So I'm looking forward to future collaboration between our research institutes.
Yeah, that would be great. Yeah, we worked with your company before, so I think we love to continue doing that.
Thank you so much for having this conversation.
You're welcome.